Hi, this is Alex from devstories.eu, Mastering Modern Pandas, episode 5 of 8. You have a list of 10 million transactions, and each one only has a customer ID. You need the actual customer names attached to those transactions. If you were writing a Python loop or using a dictionary mapping to match those IDs to names, you are wasting CPU cycles and memory. Pandas has an optimized engine specifically built for SQL-style operations in a single line. Today we are talking about relational algebra, merge and join. Before going further, let us clear up a common mix-up. People often confuse merging with concatenating. Concatenation is just physically stacking arrays on top of each other or side by side. Merge is entirely different. Merge is for relational database joins. It aligns rows from two different tables based on the values of shared keys. The core function for this is pandas.merge. It takes two data frames, which we call the left table and the right table. Think back to our transaction scenario. Your left data frame is a massive fact table containing millions of purchases. Your right data frame is a smaller dimension table containing customer details like names and email addresses. Both tables share a column called customer ID. This specific setup is called a many-to-one join. You have many transactions belonging to one single customer. When you merge them using the customer ID key, Pandas takes the single customer record from the right table and broadcasts it across all the matching transactions in the left table. Here is the key insight. The most critical parameter you control is the how argument. This dictates which keys survive the merge and make it into the final result. By default, Pandas uses an inner join. If you do not specify the how argument, the result only keeps rows where the customer ID exists in both tables. If a customer made a transaction but their record got deleted from the customer database, that transaction vanishes entirely from your merged result. To prevent losing data from your primary table, you use a left join. By passing left to the how argument, Pandas keeps every single row from your left table, which is your massive transaction list. If a transaction has a customer ID that does not exist in the right table, Pandas still keeps the transaction row but fills the missing customer details with not a number values. This is exactly the logic you want when attaching dimension details to a primary fact table. The exact opposite is a right join. Passing right keeps all rows from the customer dimension table, regardless of whether they have any matching transactions in the left table. You end up with a list of all customers, and those who haven't bought anything simply show missing values for the transaction data. Finally, there's the outer join. Pass outer to the how argument, and Pandas keeps everything. It takes the union of keys from both frames. Every transaction and every customer makes it into the final dataset, with missing values filling in the gaps wherever a perfect match is not found. The default inner join drops unmatched data silently, so unless you explicitly want to filter out rows, you should always specify a left join when attaching lookup tables to your primary dataset. That's all for this one. Thanks for listening and keep building.